Question 4. The amount in milligrams of a medicinal drug in the body t hours after it was rejected is given by the exponential function dt is equal to 23 times 0.85 to the power of t, where t is greater than or equal to 0. Before this injection, the amount of the drug in the body was 0. Write down the initial dose of drug. Well, let's just think about what's happening with this question first. When t is 0, there is no drug in the body, which sort of makes sense. And then you have an injection, and there's going to be a lot within your body at that time. Your body's then going to break it down and break it down and break it down and break it down. So we have this negative, this exponential decay function. The initial dose of the drug, so the initial dose is when t equals 0 or d equals 0. And we substitute that in, so 23 times by 0.85 to the 0 is going to be 23 milligrams. So the drug dosage when t equals 0 is 23, so that must be as high as our graph will go. Write down the percentage of the drug that leaves the body each hour. Well, it's an exponential decay function, and we're looking at this value here. 0.85 is a decimal which can be converted to 85%. So after 1 hour, there is 85% of the original amount left in the body. In U2, there's 85% of 85%. But this doesn't tell us that 85% leaves the body. We need to start at 100%. And we're going to take off 85%, which is going to leave us with a 15% reduction. So pay 85% is a 15% reduction, or there's 15% off in a sale. Your multiplier is 0.85. Calculate the amount of drug remaining in the body 10 hours after injection. So the amount of the drug after 10 hours, checking that t is in hours. T hours, yes, is going to be 23 times by our decay function, our decay percentage to the power of 10. So we're in the calculator. We're going to do 0.85 to the power of 10. Press enter, and then we're going to multiply that by 23. Our unrounded answer is 4.5281113, which is going to leave us with a value of 4.53 milligrams to 3 significant figures.